Hi there, and welcome to the first MATLAB tutorial in Appendix C from Stevens's Matrices, Vectors, and 3D Math, a game programming approach with MATLAB. And so this is the first tutorial in this chapter, and it sort of follows along with this appendix in the book. So this is the first one, running MATLAB. So we're just going to open it up, type some commands, write a little program, and see how you run such a program. Okay, so the first thing you're going to want to do is open MATLAB, and you either look for the MATLAB icon on your desktop, or you can find it from the Start menu right there. I already have it open, and when you start it for the first time, it'll probably look something like this. What you have is the MATLAB desktop right here. It's got a few windows inset into the desktop. It's a little busy for me. What I really want to work with is the command window. So I'm going to get rid of this window called the current folder. All I do is minimize that, push it to the side. Workspace, I'm going to minimize that. Now they're both off to the side. And now all I have left is the command window, and I can use this as a simple calculator. Pretty fancy calculator, the cosine of 2 times pi. Notice pi, it says pi. Right? So it's a pretty nice calculator, but we're obviously going to do a lot more than that. And so the first thing I'll do is let's make a plot. We'll do a cosine plot, right? And I'm going to type this CLC. What that does, that's called clear the console, all right? Or clear the command window. And it'll clear this window. So I do that. I'm back to a nice clean command window, which I like. So I'm going to plot cosine x. So I need some x values. So I'll let x equal, and I'll go 0 by 0.1 to 6, which is essentially 2 pi. Or I could go 2 times pi. How about that? And so there's one thing about this. If I put nothing, if I just hit enter now, what I've got is a giant output. It just gave me that list. I went the whole way from 0 to 2 pi by steps of 0.1. And it ended up at 6.2. But I don't need to see that. So if I retype that command, x equals 0 by 0.1 to 2 pi, and I just put a semicolon, that suppresses the output. So almost all of the code that is in the starter repository has semicolons at the end, because there's no need to display everything to the command window. So if I want y to be the cosine, I just go y equals cosine x. Again, I'll suppress the output with a semicolon, and then I'll plot x comma y. And when I do that, well, there's my cosine curve, right? Now I don't like having a foreground and a background, so what I do is I dock this graphics window, the figure window, into the desktop, right? So that's very nice. And if I don't like it on the left, I can grab this blue bar here, and I can say move it to the right. Right, so now everything's in front of me in an orderly fashion. Right, and let's see. Yeah, so we'll learn about different graphing options, but you can get nice quick graphs. You could do something here like grid. Suppose you wanted a grid on, would suddenly put a grid. But we'll get into those details later. So now what I want to do is create a function, or not a function. I want to create a program or a script file. So what I'm going to do is, I'm on the figure right now. So if I just go to home, I'm going to go new script, and let's see. I'm going to create a very similar curve. Only this time I'll let x. I'm going to create that same vector. So almost. Of x values. I'm going to use a command called linspace. Very handy. I'm going to go from 0 to 2 pi, and I'll do 100 points. What this did was it created a vector from 0 to 2 pi, and it has 100 equally spaced x values in that vector. And then again, I'll just let y equal, instead of cosine, let's do sine x. And then I'll do a plot x, y. And then I can also send messages to the command window with the display command, DISP. hello command window. Right. And now what I'm going to do, I want to run this. Notice every time I hit enter, nothing happened over here in the command window. That's because it's a script. It's a program file. I need to run it. But before I run it, I'm going to need to save it. So I'll just save it here. And I'll save it to my desktop, say. And we'll call it example1.m. The script files, or the program files, have a .m extension. I click save. I'm going to overwrite it. Okay. You won't, but I already have one in there called that. Great, now that it's saved, I can just run it. Change folder. Oh, okay, so what this is saying is that right now MATLAB can't find that function or that file because it's operating in a different folder. So you can do one of two things. You can create a path to that folder, but it's probably easier just to change the folder. And so that's what I generally do. I change the folder so that MATLAB operates within the folder containing this script that I just wrote. So I click change folder, and it should give me a graph here pretty soon. Oh, it did. My figure was not actually undocked. It was tabbed behind the editor. Okay, so I don't really like I don't like having to tab back and forth from these things. So I can just take that figure, or let me take the editor and I'll put it down here. Right. So there's the sine curve. And it's worth pointing out that suppose I didn't like this sine curve and I wanted to make it the cosine curve. I get rid of sine, I go cosine. I don't actually have to save it every time. If I click run, it will save and run it. I run it, I know the cosine curve, and it saved my script. Okay, so that's how you create a program or script file. It's how you run it. And here I'm going to grab one off the internet. So I'm just going to pull up an already made program. And so I'm getting this from the repository, the Quick Guide to MATLAB. And if you click on that, it's the fifth. These are all just starter or code. It's basically code. Sometimes it's starter code repository. And I already have this open in another folder, but you have to click that, unzip it, and in that folder is this example many plots. So all I have to do is double click example many plots, and notice it gets tabbed in my editor with the file that I had recently created. So what this is going to do, I'm going to run it in 1 second. Actually, I'll run it now. If I run that, I'm going to have to change that folder because that was residing in a different place. So I'll change folder so that I'm operating in the right place. I created 3 sine waves with different frequencies. So let's go back and take a look at the actual code that created this. All right. This CLC clears the command window. What it did was all that stuff that used to be in this command window, it just erased it, and so it ended up replacing it with this text, nice sine plots, right? And then this CLF, it cleared the figure so that I was able to put a new figure on top of it. And then X, this created that 0 to 6 or 0 to 2 pi, and it put 100 points in there, right? 100 evenly spaced points from 0 to 6. And now here's a little for loop. I have a counter variable I that's going to go from 1 to 3, and my Y values are going to be sine of I times X. So the first time through, it'll be sine 1x, sine 2x, sine 3x as you go through the 3 times. And then this subplot tells you which plot you're working on. So what this says is I'm going to create an array of plots, 3 rows, 1 column, and I'll build the ith row. Right? So when I was 1, it built this graph. When I was 2, it built this graph. When I was 3, it built this graph. Right? When I say built, it actually plotted them. Right? So that's how you and again, you could change it. Suppose you changed it to cosine. and you ran it again, it would save that change and it would change the plots. So I generally don't work in the command window. Right? You can type all this stuff in the command window, but then it disappears. So I do almost all of my MATLAB work in files or script or programs, whatever you want to call them. They call them script here, but they're also just programs. All right, so that is getting MATLAB started, creating some programs, running them, saving them. And the next chapter in this appendix will be, I believe, function. Yes, creating your own functions. All right, bye.